Let's do a quick little introduction to trig. First of all, let's make sure you know how to label the sides properly of a right angle triangle. Let's start with angle K. If I ask you to look at angle K and identify the three sides with respect to angle K, then you can label the side that's across from that angle but not touching angle K, which would be side ML, or side little k if you wanted to give it a letter, single letter. That side is called the opposite. That's a leg of a right angle triangle, and that's specifically called the opposite side. The side that's touching the angle K, but the side that's still a leg, because really there are two sides that touch angle K, side KM and side KL. But only one of those sides is a leg. In this case, side KL is called a leg. Specifically, it's called the adjacent leg. And the side that's across from the right angle, which is angle L, is called the hypotenuse. By definition, the hypotenuse in a right angle triangle is always the longest side, and it never changes. The whole question could change, however, if you change perspective and you redo the whole triangle, but this time we talk about the triangle with respect to angle M. I'm going to redraw it so I don't mess it up. So angle M at the top, the right angle is still at L, and the angle K is at the bottom. So now I'm going to circle angle M. I'm going to change the perspective. Therefore, with respect to angle M, the side that's across from angle M is now going to be the opposite. So side KL in the first triangle was the adjacent side, but in this triangle, when I'm talking about angle M, side KL is the opposite, and the side that's adjacent to angle M is the side that touches angle M, that's also a leg. In this case, side LM. And of course the hypotenuse doesn't change. It's always the side across from the right angle, and it's always the longest side. I'm going to put some dimensions on the triangle. I'm going to put the hypotenuse going to be marked as 13 units, centimeters, feet, whatever it happens to be, and ML is going to be 5 units. The first thing I'd ask you to do would be to help me to solve for the missing side. That requires absolutely no trig. You should be aware that the leg squared plus the leg squared equals the hypotenuse squared. So 5 squared plus KL squared is going to equal 13 squared. So rearrange the formula, solve for the leg. 13 squared is 169 minus 5 squared, bring that over, change to a minus, 25. KL squared is going to equal 144. So KL is the square root of 144, which is a 12. Now we have 3 sides in a right angle triangle. With respect to angle K, what we're going to do, identify the 3 sides. We're going to call angles the side marked 13, hypotenuse for sure. The side KL is the adjacent, and the side 5 is the opposite. Now with respect to angle K, we're going to write the opposite divided by the hypotenuse. The opposite divided by the hypotenuse would be 5 divided by 13. The adjacent divided by the hypotenuse would be 12 divided by 13. And the opposite divided by the adjacent would equal 5 divided by 12. we could take all those numbers and turn them into decimal equivalents, which we'll do. And we could also take those numbers and convert the O and the H, the A and the H into trig ratios. Think back to what we learned. Our SOHCAHTOA, the O over the H is what we refer to as the sine ratio. So the sine of angle K would equal 5 over 13, which you could change to a decimal or leave it as a fraction. The cosine of angle K, cosine is the adjacent over the hypotenuse, that would equal 12 over 13. And the tan of angle K would equal opposite over the adjacent, 5 over 12. Any one of those fractions can be converted into a decimal. So 5 divided by 13 is equal to 0.3846. 12 divided by 13 would equal take a pause for a second. Gotta grab my calculator. Fill those ones in. The sine, the cosine, and the tangent. So the theory says we can take any one of those ratios and find the value of angle K. So if we had the opposite and the hypotenuse only, that's all we had to work with. The opposite and the hypotenuse, we would find the sine ratio, and we would take the second function or the inverse sine of 0.3846 on your calculator. You would hit second function sine of the decimal equivalent, and you would get an answer for, I'll call it theta, but really it's just angle K. Use the proper, so angle K would equal 22.6 degrees. If you had used the cosine and all you had been given originally was the 12 and the 13, you could have used the cosine ratio or the adjacent of the hypotenuse and done second function cosine of 0.9231, and you would have got the same angle, 22.6. And of course the tan, angle K would equal the same thing, 22.6. And if you wanted to find angle M, you could simply subtract the 22.6 from 90 to get the other acute angle in the right angle triangle. Because don't forget that the two acute angles, angle K and angle M, have to add to give you 90, because the other corner in a right angle triangle is always a 90, which together gives you 180.